Hans.
Thank you, Kim, and thank you everyone for coming. So I was asked, I came here to speak about the business side of things. So I'm essentially neutral on the environmental issues because the equipment we make is a measurement system that measures particles, and nanotoxicology is actually the study of that at a large industry. So what Sally's doing is repeated in most universities around the world, and they are our customers. So it's not that I'm not neutral. I'm reasonably neutral about that side of it. I'm going to quickly talk about differentiation and integration and also relativity, because this is about science, and then about business. So the differentiation and integration I'm talking about is really, if you think about your human body, you can think about the human scale at the world's population at one level and go right down to atoms at another. And so when we talk about nanotechnology, we're talking about a size range that's sort of near the bottom of that, and I don't really stick with a 0 to 100 nanometers. If it's measured in nanometers, I call that nanotechnology. So there are a whole range of things that exist in nature that are nano-sized. And so there's nothing wrong with being concerned about nanoparticles in sunscreen, but I was just relating to Kim that when you go swimming in the ocean, every teaspoonful of the ocean has got 5 million nano-sized particles in it.
This is stuff I didn't want to know.
5 million per teaspoonful, and the ocean's quite large. But these things are viruses, and they're not nasty to humans, but they're nasty to bacteria. And some of the bacteria are quite important, and so 20% of global oxygen comes from these bacteria, and the viruses all interact with them. So you can't have an ocean without that ecosystem, without all the viruses in it. So, that's just part of nature. In the human body, Kim said the cells are 7,000 nanometers. Below cells, you have these things called exosomes, which are tiny nanometer-sized things, which our company measures for medical research people around the world, nanovesicles, and all sorts of other little protein structures, DNA and the like. So, incorporated in nanotechnology is a vast array of things that are integrated into a greater whole. So that the notion that nanotechnology exists in itself is not correct. So the differentiation aspect is that we're differentiating by measuring smaller and smaller things, and the integration aspect is that these smaller things are generally part of a greater whole, whether it's the human body or the ocean or a computer. So, therefore you can see nanotechnology just as part of science. So it's extensions of physics, extensions of chemistry, extensions of biology, of computer chips, all of those things. All that's happening is that the nanotechnology, the instruments are enabling people to deal with the finer scale and therefore understand the greater whole. So, as I wrote in the press yesterday, it's like not having the internet. You can't not have nanotechnology because it's all around us.
But sorry to interrupt. But isn't what you're saying sounds very much like the justification for genetic modification? Hey, we've all got genes and we know they're there and we've always been mixing them, so what we're doing is no different from what we've always done. But it is different.
Well, I don't disagree with what Sally said, that there are frivolous uses, and if it's going to cause an environmental issue and it's frivolous, it's fine. But the whole concept of nanotechnology is very large. In fact, it isn't one thing, it's lots and lots of things. You can't brand nanotechnology in one little box any more than you can brand yourself in a little box. Doesn't work, sorry. Oh. I don't know what box would be. So the point is, it's very diverse. So you have it in computer chips, which we all think are great. We couldn't live without computers. You have the study of viruses in the ocean. It's a project we're working on with MIT in Boston. That is nanotechnology. You have the detection of disease as nanotechnology. You have exosomes now as a predictor of various things that people didn't even know existed 20 years ago. You also make nanoparticles to make better solar cells. I invested some hard-won money, which was a mistake, in a company looking at thermoelectrics, which is the conversion of waste heat. I used to be in the energy industry, so there's lots and lots of waste heat directly into electricity. And the way you achieve that is you need a material that's a good heat insulator, but very good at conducting electricity. So most things are not good at that. So you try to create structure on the nanoscale that can convert the heat into electricity. Major benefits. I lost all my money, so don't worry about it.
Why did it have to be on the nanoscale?
Because that's the scale at which you're changing a structure. So in fact, the machine that they bought was called atomic layer deposition. So they create this extremely porous structure that's the lightest thing you can get, almost hollow, and then layering single atomic thick layers of various materials inside to try and get this thing to conduct the electrons away but not conduct the heat. And so you're dealing with things very fine scale. If they had succeeded in that, then you can put things on like the exhaust of a car and trap the waste heat and convert that to electricity to go and charge the battery. So anyone could see the benefit. As it happens, I just lost my money.
As it happens, the word telling.
We're a bit early. I'm an early starter, don't worry. Relativity comes about, I've moved on from differentiation and integration, from really looking at the relative scale of things. So we tend to look a little bit at things in a binary fashion. Is it yes or is it no? And really, I get a little irritated sometimes. Some of the problems that people look at with respect to now are tiny. In this case, nanotechnology is appropriate. And some are very large. And quite often, we focus on the smaller problem because it's convenient or we relate to it and ignore the very large problem. And so, if you're looking at two sides of nanotechnology, I read a study on TB, and one of our little projects was trying to find a diagnostic for TB. And the study said that an efficient, fast diagnostic would save 625,000 lives per year. We have another project looking at detecting very low levels of HIV in blood with a group in Dublin. And so you can all get that. If you could detect that at much, much lower levels, you can apply a cheap technology to the third world. Again, you're talking about hundreds of thousands of lives potentially, versus somebody might get a rash from sunscreen, or there might be, I don't know how big that problem is, but my guess is it's completely and utterly different scale to the other side of the thing. So you balance it all up. So you can't just stereotype nanotechnology and say it's all one thing. You've got this big thing over here that could be great. You've got the sunscreen, you've got the solar panels and all these other things. So it's really, you've got to see that as part of a much larger whole. There is a class of nanoparticles that cause millions of people a year to die. We should know about this. We know Michael Crichton wrote that book about the little nano beasts that all join together. These things self-replicate, and they're called viruses. And they've been around for about 3 billion years. And I suggest that when we deal with viruses in laboratory, we have fume hoods, people wear masks. We really take that quite seriously. We're not allowed to take a virus sample out of the class 2-3 lab. So people are really very, very careful and understand the issues around the dangers of those viruses. And those viruses are just a type of nanoparticle. So the nanoparticles we create, some will be relatively benign and some will be not. And there's clearly a class of them that won't be benign. The heavy metals was mentioned. We know heavy metals are dangerous anyway, whether they're in nanoparticles or in the batteries that you just throw out in your rubbish every week, they're still heavy metals. So they end up in the landfill, and what happens to them? There's nothing to do with whether they're nanoparticles or not. It's just that they're heavy metals. And then the nanoparticles isn't necessarily going to make them better or worse. So really, that's the relativity. It's important to weigh up the scale of different problems. In terms of business, you see these hyped up claims that there's going to be trillions of dollars coming out, and the claim comes because some bright spark said there's $100 worth of a catalytic converter in a $50,000 car, so we'll call the $50,000 car part of our nanotechnology. And of course it's a complete nonsense. The nanotechnology is a part of the car, but it's not the car. And so you get these silly claims. So the nanotechnology enables these things, it gets them better. So for instance, I mentioned in the newspaper yesterday about the dairy industry. I'll just use it as an example of New Zealand's largest industry. We can add some value to it. But the $10 billion dairy industry is not the nanotechnology industry just because you can apply some nanotechnology to an aspect of it. So it's vastly smaller than everybody says because the computer industry is worth trillions, but it would exist without the nanotechnology. So I think where we see the benefits, the business benefits, if you like, the economic benefits, are these incremental little improvements in a whole raft of different areas. Improvements in medical health, solar panels, clean energy, computers and all those things. And then you also see some other areas of frivolity, cosmetics and other things which really maybe the potential downside is worse than the upside. So in respect of New Zealand, I've just made some numbers up, and I have already made them up, to target, say, $100 million in exports in 5 years for nanotechnology is reasonable. I mean, our business targets are along those lines. So 2 or 3 other businesses like us would get there. Maybe $1 billion in 10 years. That's the size of the wine industry, so it's not going to transform New Zealand of itself. But I think in New Zealand we need high value growth, not low value growth, so we need fewer people doing high value things.
So you're saying that nanotechnology is is an added value.
Correct.
Rather than a whole new world.
Correct.
Can
And
I
it's
just...
incremental, yeah.
I know you haven't finished yet, but
No,
you've gone on
basically,
too
yeah.
long already.
No,
And I just wanted to check, you talked about, nanotechnology being used in earlier diagnosis of TB and early diagnosis of HIV.
They haven't, it's a potential solution rather
All
than
right, but are
actually-
you saying nanotechnology is being used in the machines that will do that?
Well, the project around HIV is to use magnetic particles, which are tiny, they're actually a few hundred nanometers, and you attach an antibody, which is a molecule in your blood, put that into the blood. The antibody is designed to attach to the virus. You then take the magnetic nanoparticles, measure them in our instrument, and we can tell where the virus is there or not, how many of them there are. And so we've calculated in theory that we can measure HIV viruses in blood at 1/10 of the level that they currently do, and at probably about 1/10 of the price if the whole thing was successful. So that would then enable very early detection of HIV, monitoring people on drug therapy, but most of all, it's cheap enough to use where most people have HIV, which is the third world. So that is not, nanotechnology is not the answer, it's only one part of it.
No.
Is it 5% or 10%? Not the whole thing.
It'd be, I mean, that would be interesting in itself, given the difficulties that third world people have in accessing any drugs.
Yeah, that's
Even
right.
in the later stages of HIV,
absolutely.
earlier diagnosis of HIV is going to mean what? But
they,
that's
but they
not
do
your
the
issue.
test in the UK and they cost £100 each. And so I've got a friend who works in that field, and so they might test somebody 3-4 times a year. This is never going to happen in the third world. If you could do it for £1 each, it might.
All right. Have you finished?
Yes, I am.
For the
Thank
time
you.
being.
Absolutely.
Peter Dawson.
Thank you, Kim. Yes, I've been asked to speak on basically on the role of the government regulator in relation to nanotechnologies, which is a little bit of a daunting task because, like we've heard, with all new modern technologies, the pace of change and the potential uses of nanotechnology are sort of expanding exponentially. And in general, the role of a government health and environmental regulator in respect of new technologies is to seek to manage the potential risks of these in such a way that still allows people to use these new technologies for the benefit of society and the economy while avoiding any adverse effects. That is, the regulator seeks to neither allow unacceptable risks to go unmanaged nor to stifle innovation and economic growth. In doing this, with something like nanotechnology, there's two factors which influence our role. First is the question of risk. Well, there is no such thing as zero risk in life. Almost every technology or product has an element of risk with it. And again, it's the role of the regulator to see that those risks are managed, but not necessarily eliminated. And I had an example, which is a bit of a trivial example, but I'll read it out anyway, which is the case of petrol. Now, if petrol was a new chemical that came to us as a chemicals regulator now, it may well be declined because of its hazardous properties and the risks associated with it. It's a highly flammable substance, it's very poisonous, harmful to the environment, and as well as being a suspected carcinogen. Yet petrol obviously has significant benefits, and society as we know it today couldn't exist without it. But with something like petrol, we obviously know and understand those risks, and as a society we've grown to accept them. But what regulators seek to do is to provide a set of rules to manage those risks so that we can continue to enjoy the benefits as safely as possible. The second factor is that in making any sort of regulatory decision, especially in relation to a new rapidly developing technology area, is that we often will not know everything, as we've just been hearing, about the risks of a new technology and a product. And again, this goes back to uncertainty is a fact of life with anything new. And manufactured nanomaterials are not a unique case of this by any stretch of the imagination. And as regulators, we can only work with the information that's available. Like I said, you can't really stop things dead in the water until such time as you've got total certainty, otherwise we'd never evolve as a society. Where there are data gaps, though, we have to make a judgment call on this level of uncertainty and whether it's acceptable or not acceptable. So, and we obviously have to work within the constraints of the legislation that we've been given by the government. So it doesn't mean that regulators should automatically restrict something when there is little or no evidence of harm.
Is there any legislation that applies specifically to nanoparticles?
No, there's no legislation that specifically relates to nanoparticles, but there's an awful lot of legislation that is equally applicable to nano forms of chemicals as they are to non-nano forms of chemicals.
Such as?
Well, such as the legislation that we deal with at our agency, the HASNO Act, the Hazardous Substances and New Organisms Act, which we can no doubt talk about later, but that is certainly covers nanomaterials within its scope.
You mean that manufacturers or importers are supposed to report the existence of nanoparticles to ERMA?
That only applies in respect of cosmetics. So that is a particular provision we have in respect of cosmetics. But
And how many have?
a small number.
How many?
I'm not sure the exact number, but it's probably about 5 or 6.
And the consensus seems to be that most cosmetics contain nanoparticles.
I don't know that that's true, that you'd say most.
Sunscreens?
A lot of sunscreens do, but again, it's only those ones that contain the, like the zinc oxide, titanium dioxide based
They
ones.
have to say, yes, we've got this in it. And you have to say, I'll come to you in a moment. And you have to say, yes, that's safe. I mean, I'm trying to work out how you're keeping tabs on it.
Yeah, we're, with those sunscreens, because when we put this new legislation in place for cosmetics, it was already well known that some of those nano mineral materials, zinc oxide, titanium dioxide, were already in nanomaterials. We do not require people to notify us of those because they're known to be there. But if people were
You mean because they're safe?
Well, we have not done any evaluation of them specifically in New Zealand. But
So who are you relying on? And I'm not trying to give you such a hard time early in the stage, but I'm just trying to work out how it works. Who are you relying on to tell you, first of all, these things are in this stuff that we're selling, and second of all, but it's okay?
Right. Well, in relation to those, the mineral nanoforms, the zinc and the titanium,
Yeah.
we basically rely on them being safe from the work done by our overseas counterpart regulatory agencies in Australia and work out of the OECD in UK and so on. In relation to other nanomaterials, there is this requirement, like I say, to people for people to notify us if they are putting these new forms of material in there. And to be honest, there has only been a handful of the notifications, and when you analyse the notifications, a lot of them don't actually turn out to be nanomaterials at all.
Really?
Well, yeah. I think there's probably a lot of applications, like I think was indicated, that where people are claiming that they've got nanosilver or nanomaterials and so on, and they don't. It's not really a nano product at all.
You mean as a marketing ploy?
Marketing ploy, yeah, which I think is probably getting less sustainable these days.
Oh. Sorry to interrupt.
Yeah, okay, where did I get up to? So, I mean, but basically there is, so, yeah, I don't want to cover up the fact that there is a lot of uncertainty in the regulatory spheres for nanomaterials.
I don't think you've covered that up at all.
But it's like like I said before, you don't go out and regulate things for the sake of it. There has to be some evidence of harm being caused before the government will accept, compliance costs being put on industry and the hindering of innovation. So, but a very large amount of work is underway both in New Zealand and overseas in the regulatory sphere to give greater certainty about the safety of manufactured nanomaterials. New Zealand is working very closely with the international community and, like I said, our fellow regulators in the regulation of these materials. In fact, we're in a very similar regulatory space to most overseas jurisdictions. Everybody is still sort of trying to grasp the issue. So we're neither lagging behind our counterparts overseas, nor are we taking the lead. We're very much actively involved in an OECD working party on manufactured nanomaterials, which is seeking to address the health and environmental safety implications of these things. And there's a lot of work going on in that area. We've also had within New Zealand an interagency government agency working group for several years now, working with people from across a variety of agencies, Ministry of Health, Food Standards people, Ministry for Environment and Department of Labour and so on. And the purpose of that group is obviously to share information and coordinate our discussions and develop advice for government on the environmental health and safety risks of nanotechnologies and the regulatory approaches that should be adopted to address these. And this is obviously helping to facilitate the formation of a consistent whole-of-government approach to nanotechnology.
What's your attitude towards fullerenes, which are in some of the anti-aging cosmetic creams, as I understand it, and there's a voluntary moratorium on fullerenes in Europe. Have we approached that at all? Do you worry about those?
Well, fullerenes have not been notified to us as being present in cosmetics in New Zealand. So in fact, fullerenes haven't been notified to us at all as being in any product that we need to assess. So we have never carried out a toxicological or health risk assessment of those.
With all due respect, should somebody be being less passive about this? You know, you're not going to do anything until something happens.
Well,
I mean,
it's easy to say
you're
that, but
stuck with the regulation.
yeah,
No, I understand that. But do you think that there is a case for being slightly more proactive?
There is always a case for being more proactive, but of course that does require resources. I mean, even with cosmetics, we have a number of detailed regulations regarding cosmetics, and there are non-compliances with the, if you like, the non-nano aspects of cosmetics from time to time. I mean, occasionally you get reported that there are lead-containing chemicals in ladies' lipsticks, for example. Or there may be too much.
Or even men's lipstick.
Yes, I wouldn't know so much about those myself, but
But who finds that out?
that can be found out. There's a number of agencies that are involved in this, in the regulation of chemical-based products in New Zealand. But the Ministry of Health would be the agency that's responsible for that.
So they're testing for lead in lipstick, but they're not testing for nanoparticles.
Basically, yes, there is not, as we've heard, tests for nanoparticles. So the compliance, I mean, it's like the vast bulk of government legislation. The compliance with that does generally rely on the goodwill of the people being regulated. I mean, everybody's supposed to drive at under 100 kilometres an hour, and by and large, most people do, but you can't guarantee that everyone's going to stick to that all the time. But just getting back to what I was saying, so just more recently, the Ministry of Science and Innovation has been leading a review of all the current New Zealand legislation to see if it's appropriate and adequate to manage the potential risks of manufactured nanomaterials. Like I said, in some ways, nanomaterials are still chemicals. They're just a slightly different form of them.
Smaller.
Yeah, but then you've got to sort of look. I mean, they're smaller, but they're not as small as when the chemical is actually dissolved in liquid solution. So, for example, we talk about nanosilver particles. You can obviously get silver dissolved up in solution, and that silver dissolved up in solution is more bioavailable to the body than a nano solid form, because nanomaterials are still a solid form.
I may have to leave this up to Georgia, but I think the point is that nanosilver could well eventually dissolve in the water supply or whatever, at which point it will become a problem, even if it's not a problem before that, surely.
Well, that does get back to the point that was raised before about heavy metal, nanoforms of heavy metals, which, they're toxic and harmful to the environment purely because of their chemical nature. It's not the fact that they're in a nanoform doesn't really make them.
But presumably if nano anything is an enhancement, have I got this wrong? If nano anything is an enhancement and people start shoving it into things, then that will increase the amount of heavy metal in the environment. QED.
Yeah.
Wouldn't it?
Yep.
Okay. Just cumulatively?
Yep.
Okay. Sorry.
Can I interrupt? and
Yes.
say no?
Well, yeah, you can.
Because actually you use it more efficiently, so you could quite likely end up with less. So it's not true at all that you might end up with more.
Oh, good point. but I have to get to the end of the table. Sorry, Peter.
Okay,
Wrapping up.
I haven't got much to go yet. So this review that has been done of current legislation, which has not quite been finalised yet, and it will be published by the government in due course. But the preliminary indications are that the legislative framework is fundamentally robust and flexible enough to deal with manufactured nanomaterials and does not require wholesale changes. I mean, and that's a similar finding to the overseas studies. That's not to say there won't be some indication that there are certain areas where things could be enhanced. So just in conclusion, like all new and emerging technologies, there is still much to be learnt about nanomaterials. Indeed, many of the technology's most innovative applications may be years away from realisation. In the meantime, the majority of applications of nanomaterials that are in use is considered by government agencies to be able to be regulated and managed through the existing legislation. And the regulators, through the work both in New Zealand and internationally, are actively working to ensure people and the environment remain protected.
Thank you.